Okay, today we're going to review a few things about circles, circumference and area, and then we're going to talk about how to find the measure of arcs, arc lengths, and sector areas. So real quickly, let's go through and review some of these things. A radius is a segment with endpoints at the center and on the circle. Some examples of a radius in this drawing right here would be CF, CE, and CD. Okay. A chord is a segment with endpoints on the circle. AB is an example of a chord. It's got endpoints on the circle. Now the difference between AB and DE is that DE passes through the center of the circle. We call that the diameter. And segment DE is an example of the diameter. Concentric circles, just a vocab word here, are coplanar circles. They're circles that share the same center. So you have this smaller circle, and then you have this larger circle, but both of them have A as their center. The circumference formula is 2 pi r. Now, this drawing right here, let's magnify that, and I'll let you read that while we kind of look closely at this. So make sure you have your notes with you. But it says that the radius of circle X is 22 units, so this distance is 22. Now it also says that the radius of circle Y is 16. And then it goes on to say that WZ, distance between these 2 points, is 5. What's the length of this entire segment, XY? Well, I can't just add 22 and 16 because they overlap a little bit. But I can find, if I go 16 units this way, the rest of this way is going to be 22 minus the 5 right here, which is 17. So this segment is 17. 17 plus 16 is 33 units. And that would be the length of XY. Okay. The next question is an example of working backwards. Find the diameter and the radius. So that's going to be my answer to the nearest hundredth if the circumference of the circle is 65.4 feet. So 65.4 is my circumference. The circumference formula is 2 pi r. If we divide both sides by 2 pi, that will isolate my r, which is my radius. That cancels out. Just a word of warning, if you're using your calculator, make sure you put 2 pi in parentheses. Otherwise, it will divide 65.4 by 2 and then multiply times pi, and you'll get the incorrect answer. When you do that, 65.4 divided by 2 pi, it leaves you with, rounded to the nearest tenth place, is 10.4 feet. And of course, to find the diameter, all we do is double that because the diameter is twice the radius, which would mean that the diameter is 20.8 feet. Okay, continuing on with the next question. Here we need to find the circumference. Exact means we're going to leave it in terms of pi. Now in order to find the circumference, which is 2 pi r, we need the radius. This circle doesn't have the radius. This is the radius, and this is the radius. So what we end up with, I'm going to just draw that triangle again, is a right isosceles, which means it's a 45, 45, 90 triangle. If the hypotenuse is 3 radical 2, you'll recall the shortcut is, if I want to find my leg length, I divide by radical 2. So 3 radical 2 divided by radical 2 ends up equaling 3. That is my radius. So if I'm finding my exact circumference, 2 times pi times 3, I end up with 6 pi. That's my answer. That's my exact circumference. I'm not rounding it. I leave it in terms of pi when it asks for the exact circumference. Okay, a couple more terms here. Central angle of a circle is an angle with the vertex in the center. This is a central angle. It's this vertex. The center of the circle is the vertex of that angle, x. In fact, all of these angles are central angles. Its sides contain two. You'll notice that the sides are all the same length. They are the radii of the circle. The sum of the measures of the central angle of a circle is, this is pretty simple, we'd get it, makes sense. It's one rotation around the circle, which would be 360 degrees. Okay, a minor arc, what a minor arc is, it's the shortest distance arc connecting two endpoints on a circle. So for instance, if I had arc GH, and I was talking to you about what's the shortest distance, the minor arc between those 2 points, this would be the shortest distance as opposed to going around and crossing through J. That's a minor arc. The major arc would be this arc, and we would call that arc GJH. So you can use 2 letters or 3. Third letter clarifies which direction you're going. And the major arc is the longest arc connecting 2 endpoints on a circle. And of course the semicircle, if, looking at this drawing below right here, this arc, if G and J are if segment GJ is the diameter, well, there's no major or minor. It's a semicircle, so it lies on the diameter. It has to lie on the diameter if it's a semicircle. Okay, and the last thing here is the measure of an arc, and this is important to know as part of the assignment today. The measure of an arc is equal to the measure of the central angle. So, looking at that circle right here, notice this central angle is 122. Well, this arc is going to also be 122 degrees. This is a semicircle. The angle here is 180, so the arc measure is 180 degrees. And the last one, well, since they all have to add up to 360 degrees, and 122 plus HJ has to be 180, that would leave us with 58, which means the central angle here is also 58 degrees, since they're equal. Okay, the area of a circle formula is going to be pi r squared. And with that, that's going to move us into some of the more difficult questions dealing with arc lengths and sector areas. So a portion of a circle, like the crust of a pizza, is called an arc. This is a set of connected points at fixed distance from the central point. Points on the circle. The length of an arc is part of the circle's circumference. If a circle has a radius of 6, find the length of an arc with a central angle of 30. So basically we're saying that we have a central angle of 30. What's the length? Now, not the arc measure. The arc measure would be a degree value. The length is if we grabbed some way of measuring this out. Well, it already said that the circumference is the distance around the entire circle. So let's find the circumference. Again, that's going to be 2 pi r, with the radius being 6, which means that my circumference of the whole circle is 12 pi. Now, this is just a portion of the full circumference, but what portion is it? Well, if you'll notice, it's not half, it's not a fourth, but there is a way we can figure out what fractional portion it is. We take the central angle over 360. So we're going to multiply the complete circumference by 30, the central angle, over 360. And when you do that, let's go ahead and leave this in terms of pi. When you plug that into your calculator, you should get pi as your answer. And we're talking about centimeters. Don't think that pi is a variable. Pi is a value. 3.14, continuing on and on. So that would be the length of that arc right there. Now we do the same thing when we're doing a sector. We're finding the area. The only difference is this time we find the area of the entire circle and then multiply it times the fraction that makes up the circle. So the area formula is pi r squared. So pi times radius squared. Radius is 10 squared. So basically that ends up being 100 pi. Notice the central angle is 20. So just like we did up here, central angle is 20 over 360. So when I multiply 100 pi times 20 over 360, I round to the nearest tenth, I get 17.5. We're talking square feet because we're talking area. All right, and let's go ahead and skip down to these two problems right here. This one right here, we're going to find the length of arc ZY. So we need to know what this length is right here. Excuse me. Okay, so we need to find the circumference of the whole circle. So 2 pi times the radius. Oh, excuse me. Which is 4. So 2 pi times 4 is 8 pi. We multiply the circumference by the central angle over 3060. 75 over 360, and that will give me my arc length. When I do that work, if you leave it in terms of pi, it ends up being 5 pi over 3. Or you toggle it, and we'll round it to, excuse me, 5.24 to the nearest hundredth. And we're talking inches. Okay, and we'll do it again. This one again, we're looking for the arc length of ZY. So the circumference of the circle, be careful here, 10 is the diameter, which means the radius is half of that, so it's 5. So 2 pi times the radius will give us a circumference of 10 pi. Multiply that by the arc central angle, 130 over 360. And when you do that, you should get, in terms of pi, 65 pi over 18. We're talking centimeters. Or if you round it to the nearest tenths place or hundredth, you should get 11.35 centimeters. Okay, and the last question in the notes, we're doing the same thing now with the area. So we need to find the area of the entire circle, and to do that we use the pi r squared formula. So pi times the radius, which in this case is 22 squared, that's going to be 484 pi. We multiply the area times the central angle over 360. When we do that, round it to the nearest tenth, we get 570.2 inches, square units, because we're talking about area. Okay, looking at this first page of the assignment, the first section looks fairly easy, naming parts of the circle. We did some problems like this in the notes, so be prepared to look at that. Number 9 is kind of tricky. You need to find the circumference of the circle, but to find the circumference, you use the formula 2 pi r. You need the radius. Well, you don't have the radius, but you notice that you do have a right triangle whose hypotenuse is the diameter. So if you use the Pythagorean theorem, you can find out what this segment's length is. Whenever you get that, divide it by 2 to find the radius, and then you can plug it in the circumference formula. You need to find the circumference on number 33. You don't have the radius, but you know that the diameter is 14, therefore the radius is half of that, which is 7. This question is pretty tricky. I would recommend finding the area of the entire square first. It's 10 by 10, so it's going to be 100 square units. Then subtract the area of the circle. Now remember, the circle's diameter in this case is also 10, so the radius is 5. You use the formula pi r squared to find the area of the circle. The radius is 5, so we square that. So we're going to subtract 25 pi from that. What that's going to leave you with is the little pockets of space right here inside of the square. Well, notice that the shaded area only counts for one of those 4 pockets. They're all equal size, so you would divide whatever you get by 4 to get your answer. So there's just some help. I'll let you figure out the rest of that. And right here, these problems, you're going to be dealing with major, minor arc, their central angles adding up to 360 degrees. Number 10 is where you will start to use the measure arc length. You'll recall that you find the circumference of the circle, multiply it times the central angle over 360. And both of these problems are like that. And 14 and 16 here, you're working your way backwards. So I'll let you do that. You're going to set the area 68 equal to the area formula, and then solve for r to find the diameter, because then once you find the radius, just multiply it by 2. The following 4 questions, these are where you're going to find the area of the circle, the whole circle, and then multiply it by the central angle over 360, just like some of the examples from the notes. All right, hopefully this helps.